go ahead and open up the census dataset starter code provided to you. When you do this, you need to actually make your own copy. You can't actually make copies on mine, meaning you can't like adjust the code. So you want to go to File, Save a Copy in Drive, do that now. And then when you do that, you'll create a copy, open up a new window, just call it something that makes sense, like census dataset. Okay. This is taken, so I copied this in for you all. This is taken from the UCI machine learning repository. I want to show it to you briefly because it's cool. UCI machine learning repository, just search that in Google, go past the ads, and it's the first link. It is a very popular warehouse for storing machine learning data sets. This is actually the second one. It's called Adult also. It's the census of adults. And there's a lot of other stuff in here you can look for, but if you click on any of them, the way you actually access these, if you click in the data folder, you put the data file in name, Command C, Command V, into that URL. And if you copy that all, Command C, go back to the file, there it is. Okay, that's how you get the proper URL. You cannot copy most URLs as CSV files. It's not going to work. There are very few ways. This is one of the ways. Okay, then you import pandas as PD, read it in the URL. Header equals none. The reason why is because the columns aren't there, so it just wastes a row. So instead, you put header equals none and then add the columns after. Now let us all add into this as well, df.head to look at the data. Okay, so go ahead and run that. Let's see what we got here. So we've got some different columns. Go to the far column at the end, it's income. This is what we're trying to predict. Is income greater than or less than 50K based on all this other information? So this one has a lot of text columns, right? And if you want to do the df.info, you can check, looks like 32,000 rows, all non-null, so that's great. But all these objects are text columns, and that's an issue. So we actually need to fix that. We're going to do that now. There's a shortcut to convert them into numeric columns. However, the idea is that we're going to use the shortcut is basically for non-ordinal columns, meaning not ordered. If you look at education, education is an ordered column. There's a clear order, like bachelor's is greater than high school grade, greater than 11th grade, right? But you also have this column here, education num 13, 13, 9, 7. So this has already been converted into a numeric column. You don't need that column. It's actually wasted, so we can delete it. Okay, so let's do that now. Delete extra column. And you can try delete df brackets education. Yeah, just education, because education num is the good one. And then what you do to convert text columns is df, you reassign it to its pd.getDummies for dummy variables of the data frame. Okay, and then let's go ahead and look at show new df. Okay, so go ahead and enter that code and then look at the results. And let's talk about it. All right, so it starts with work class. So it separates the columns to the left are all previously numeric, but working class was a text column. Now, the way they write it is working class underscore, what were the text columns, the entries? Was it question mark, federal gov, local gov? As a teacher, I'm not sure. Does that count as federal gov maybe? Never worked, or private, self-employed. And you can start to see some of the values here. So the last three in the header were all private, was the working class. And we have working class of self-employed and working class of state governor. So basically the way PD.getDummies works, it simply converts everything to a 0 except for a 1 when that's the case. Like this first row, the working class is someone who works in the state government. Maybe that's me, California state teacher. So this is how PD.getDummies works. It's basically 0 is absence, 1 is presence. It's really nice. And if you check df.info, Can recheck it. You can see a lot of new columns, but they're all numeric. That's what it does. So UINT is like does not taking up extra space. Now, there's one little issue before we do machine learning here. Again, if we start machine learning now, you're going to get that 1.0, perfect predictions. Well, wait a minute. Okay, if you just like blindly said, hey, I want to predict this column using all the others, well, guess what? It's easy if you have this one, right? Because, you want to look at the data. Might be a little more clear. Scroll all the way to the end. Well, look, if this is a 1, this is a 0, and vice versa. So the machine learning model will easily learn, oh, just subtract 1. Or if it's a decision tree, it'll be like, hey, if income less than 50K is greater than or equal to 1, output 0, else output 1. One tree done. And one branch is what I mean of the tree. So that's too easy. You have to get rid of that column. You wouldn't know that column. Okay, we got to get rid of it. So once again, delete extraneous column. This is essential. Do this now. You can really do either of them. I'm going to delete the income less than or equal. So I think it's better greater than. Okay. And now we are ready for machine learning. So press Shift Enter. Let's get a new text header in here. Machine learning. So because all the outputs are zeros and ones, this is regression. We're going to use logistic regression. Okay. So let's build and score logistic regression model using sklearn. Okay, so here we go. Code with me. From sklearn.linear model, that's where it lives. Because it's like a curve, it's like a line in mathematical parlance. Import logistic regression. And then from, that's done. Now we set model equal to logistic regression. Okay, parentheses. And then we want to fit the model, model.fit on. Oh, wait a minute. Remember, we need to split this into a training set and a test set. Okay, so hold up here. We didn't even get it X and Y yet. I'm jumping the gun. Sorry, guys. Let's first get everything ready for machine learning. I do this a lot. I get so anxious with machine learning, I'm just ready to dive in. Okay, so what we're going to do first is split data into X and Y. And because of the way we set it up, we can do the standard X equals df.iloc, all rows, all columns except for the last, and Y equals df.iloc, all rows, just the last column. Okay, and now we're going to do train test split. Split data into training and test set. Okay, there's a special way to do that with scikit-learn, and it is as follows: from sklearn.model selection import train test split, and then we can do it's a bit of a mouthful. Here we go. Do this with me: xtrain, comma, xtest, comma, ytrain, comma, ytest, so 4 tuple equals train test split of X and Y. Okay, so now back down to logistic regression, we want to do model.fit on xtrain and ytrain. Now for logistic regression, we're just going to go ahead and do the score because it's going to get accuracy, the percentage correct, so it's okay. So let's just score it on X test and Y test. Let's see what we get. You ready? I'm always excited to see the machine learning scores, right? It's kind of fun. So in this case, 100% means A, every prediction is correct, 50% half correct, 75 3/4. What do we get? Shift enter, 80%. Totally respectable. Okay, the next thing I want to do, excuse me, is put this into a function and just for the fun of it, look at some different classifiers. Okay, so let's do this now. We're going to write function that takes ML classifier as input and return score as output. Right, so how do we do that? Well, we got to use Python syntax, so def for function. You could call it different things. You could just call it classifier maybe. And then the input's a model. Now, when you input the model, you don't actually have to like separately initialize it. So you can just do model.fit on X train and Y train. And then let's just return the score. Return model.score X test, Y test. So pretty simple function. But that's the thing is deep code. That model.fit is powerful. Shift enter to run it. Now let's pick some classifiers. So let me just show you what all we can do. Let's have fun here. All right, what do we got? We already did a logistic regression. Oh, importantly, if you got an error with logistic regression, that's going to happen because you don't get enough iterations. Set max iter to 5,000. Looks like it converged here, so it's not necessary. Okay, let's have a contest. So from sklearn.tree import, we're going to import a decision tree. Now you tell me which one. Is it the decision tree classifier or the decision tree regressor? What kind of a data set is this? Well, it says classifier everywhere, so it's classifier, right? It's because it's split into two separate classes. Okay, from sklearn.ensemble. Ensemble multiple machine learning models. Import random forest classifier, right? From xgboost. Import xgb classifier. What else do we got? From is it kneighbors? I'm sorry, from sklearn.neighbors import kneighbors classifier. There's really a lot of, you can't get them all. By the way, if you want to know, you want to see how many there are? Let's see if we can get in a Google search. sklearn, that's what we're using. Classifiers. Let's see if there's an official list. I don't know. I know you can find it. I just want to see if there is. Oh, here's a lot. That's kind of cool. A lot of cool stuff. You know, you can see decision tree, random forest, A to boost, Gaussian MB, all kinds of stuff in there. I'm not going to do overkill with this. I know these. I know how to use these. Usually, though, you use them all the same way, so you can throw in some more if you want. This is enough for me for now. Okay, so now what we can do is we can just do them one at a time in our classifier, right? So for instance, if we try the first one, decision tree classifier, we don't have to worry about it overfitting because even though it'll overfit, the score is going to be on the test data. And I'm going to show you how to stop it from overfitting. And see, it actually did fine. It got 81 point, it did better actually than the logistic regression. Got 81.2%. Go ahead and put them all in, okay, one at a time. And you can totally go in and try other sklearn ones. So I just keep typing in classifier. Let's see how the random forest does. By the way, it's taking some time because 86%, nice. These are accuracy. Random forest is 100 decision trees. Okay, well look, there's 30,000 rows. Let's say about 100 columns, so that's like, is that like 3 million entries already? Is that right? 30,000 times 100 is 3 million entries in this data set. And then times 100 trees. That's 300 million kind of like, points it's going through. Similarly with XGBoost, here's the difference. A random forest is actually a bunch of random decision trees and it takes the average. Okay, there's some randomization involved. If they're all the same, then you could just do one decision tree because you get the same as the average as the whole. XGBoost, it learns from the errors. Now, I don't know if it'll do better in this case, but I can tell you on average it does better. But random forest and XGBoost are generally speaking, it does do a little better. Your two best bets for classification with tabular data. This is all so far in tabular data. And tabular data is basically rows and columns of numbers. We're going to be shifting, right, in upcoming weeks to use images and text. So these will not be the best methods. Deep learning will be the best. So That's an introduction to classification and actually to converting text into data. Excellent job. And again, if you want to have a little fun, you could try some of these, like, where were they? Down here, right? Like different classifiers, SVC, and so on. Oh, I did say I would show you how to stop it from overfitting. The simplest thing you can do is there's a hyperparameter called max depth, and it's like how deep the decision trees is, like how many games of 20 questions do you play. If you play just 20 questions, it's max depth of 20. Let's try that and see, it did better. Isn't that interesting? But you could go smaller. I don't know if going smaller will go better, but the point is you can actually, there's a hyperparameter, you can play around with it and have fun. Look at that. Look at that. It's moving up big time, right? Because it prevents it from overfitting the data. It gives it a chance to generalize well. It's catching the random forest classifier. That would be hard to top. You can actually do the same thing in all of these. These three, decision tree, random forest, and XGBoost, are all classifiers. Oh, I forgot k-nearest neighbors. Excuse me. It tends not to do as well, but it's kind of fun. And the reason why is because the in neighbors is the class of, like, you can change it. See, the default is 5. Let's check the default. What it does, you would think it would actually do better. It finds the 5 nearest neighbors, okay, which 5 rows are the closest to it, and it matches basically the mean of those outputs. And maybe 5 is not enough. Maybe you need like 15. It's got 30,000 rows. It does a little better, right? What if we go up higher, 20? This is about the same. So what we're learning here is that, and this will be a key theme throughout this course, that machine learning models tend to have, they're called hyperparameters here because the parameters are what the machine learning models find the weights. The hyperparameters, you set them in advance and the machine learning models use them, but this is what you adjust to kind of tweak and make the model stronger. So there you have a lot of great info. You guys are amazing. I know it's a lot in one day. A lot of great stuff coming your way. Keep up the fabulous work.